Okay, we have a few problems here we want to look at real quickly. We have this first problem, 2 times the quantity x minus 3 is greater than -4. Now, first thing we have to do here is simplify this left-hand side because you got 2 multiplied by everything in this parentheses. For this, you use the distributive law. So we multiply 2 times x, and then we multiply 2 times 3. 2 multiplies x, 2 multiplies -3. It's in parentheses, 2 multiplies every term in parentheses. Okay, so we want to make sure we understand that step. And that's greater than -4. And then we simplify. You get 2x minus 6 greater than -4. Then we add 6 to both sides. Now I'm going to write it this way. I'm going to write 2x minus 6. I'm going to write greater than -4. Leaving myself room here. Insert what we know we need to do, okay? Which is add 6. So let me emphasize that what we've done here, we've taken everything on this side and written it down here, taken everything here and written it down here. Okay. I'm not going to do much of the thing where you put a +6 here and a +6 here without even an equal sign. Okay? Because that's what people do. And I'm seeing way too many mistakes in all my co-requisite and developmental classes. Okay? Not only that, in my actual pre-calculus class, I see people making mistakes by doing that. So I'm going to say, I'm not going to say that. I'm not going to do that anymore. I'm doing this. I don't want to see mistakes made the other way. So if you insist on doing it the other way, which is the way you've been taught, which unfortunately didn't work real well for a lot of people. And if it worked for you, that's fine. If you're not making mistakes, please go ahead and do it. But I'm abandoning that. I was kind of okay with it for a while, but I'm not okay with it anymore. Okay, so we write this side down here. We write this side down here, and we put the +6 here and the +6 here. We don't write this. And if we do write this, we want to write an equal sign here so we understand what we're doing. And then this. And then people try to add the 6 to the 2, multiply the 6 by the -4, all kinds of mistakes. Okay? Because people aren't understanding what they do. So we're not going to do this. We're not forbidding it. You're welcome to use it if it works, if you do it right. But I think we go to the way it's been done for hundreds of years. Okay. This is kind of new within the last 15 years or so, maybe longer. People started teaching it this way. It's not worth it. Okay, so anyhow, enough commentary. We add since I wrote this out here, we add 6 to both sides, and this is how we do it. If we're ever making mistakes by doing it like this, and most people are, okay? You're less likely to make a mistake. So now we've got 2x minus 6 plus 6. Well, that's 2x. Minus 6 plus 6 is 0. And this is -4 plus 6, that's 2. Then solve for x, we divide. Both sides, get 2x over 2 greater than 2 over 2. You know, 2x over 2 is just x. 2 over 2 is 1. People at equal signs don't do that. Okay. And x is greater than 1. There's a solution. Okay. The second problem, negative 3x plus 7. Less than or equal to 5. We add negative 7 to both sides. I'm not going to write out both sides. It takes up word space and takes time. We add negative 7, understanding that we're adding to both sides. Negative 3x plus 7 minus 7 less than or equal to 5 minus 7. And we see that again, we've got this side right here and this side right here. And we've subtracted 7 from this side and we've subtracted 7 from this side. Why did we do that? Well, we know that negative 3x is 7 minus 7 is 0. It's less than negative 2. Then we need to divide by negative 3. Now it's easy to write it down like this, but that's wrong. Why is it wrong? Because we divided by a negative, we reverse signs. Because that's the rule. Everybody that's here today is doing a good job of that. See, paid attention, got that rule down. Still having some trouble with some of these steps, but this step, we're good. Okay, well then we simplify, we get x greater than or equal to 2/3. Because of course negative divided by a negative is a positive. Okay. So there it is. And then the last one kind of combines what we've seen on these two. I don't have to do this, so let's do it here. 3 2x minus 6 is greater than 4 times 3x plus 5. Well, distributive law says we've got to multiply 3 by this and by this. That's 3 times 2x minus 3 times 6 is greater than 4 times 3x plus 4 times 5. We simplify this. We get 6x minus 18 greater than 12x plus 20. Okay, well, we proceed to get our numbers on the right side. So we write out 6x minus 18. We write out 12x plus 20. And again, I'm going to use the blue chalk circle. It's in this step. Circle what's in this step. At this stage, this line is exactly the same as this one. Now, if I add 18 to this side and add 18 to this side, they're still equal. Because if this is equal to this, then 18 more than this is equal to 18 more than this. Okay, this gives us 6x greater than 12x plus 38. Now, it can be a little confusing. We've got x's on both sides. Well, we've got the numbers on this side, so we probably ought to put the x's on this side, which is what we usually do. It's kind of a convention. But if you end up with the x's on this side and the numbers on this side, still okay. You can always reverse the sides as long as you keep track of the direction of the inequality. Okay, so we have 6x greater than 12x plus 38. This is the same as this. And this is the same as this. So this is exactly the same as this. And then if we subtract 12x from both sides, well, the 12x minus the 12x gives us 0. We just end up with 38. So we have 38 here. And we have negative 6x here. 6x minus 12x is negative 6x. Then we divide by negative 6. Is that right? Say yes or no. Two agreeable. Okay. Most of you saying, that's right, it isn't. I divided by a negative, didn't I? Then I just kind of reflexively wrote down the greater than sign. You always got to be careful when you write sign and inequality. You got to be careful that you didn't just divide or multiply by a negative number, because if you did, you got to reverse the inequality. Now we get x is less than. Of course, 38 over negative 6, we write it negative 38 over 6. Divide the positive number by a negative number, so we get a negative number. We get 38 over 6. Now we've got one step of simplification here. $38 over 6 is 19 over 3. Reduces. Okay. So there it is. And that's pretty much put it this way. We can do these inequalities of this nature without making mistakes. Then we're pretty good with inequalities. Now there's some weird things can happen with inequalities. They get a little more complicated, but this is a good nucleus. Okay. Now, I wrote this problem down. Of course, now I don't have room in these boards to do it, but I can put this forward and we can see to that. And so the other assignment that was done for today was on introduction to graphing. And toward the end of that assignment, everybody I think did quite well. It's just graphing points and so forth. And most people did real well when they got to graphing the straight lines. So it's pretty good. So we're going to take that another step. You have 3x minus 5y equals 30. Okay. If they find x if y equals 0. Okay. Well, three x minus 5 times 0 equals 30. If y is 0, make y 0. Okay. Now, can you tell me what x is? Okay. So, well, you should work this out if you're a distant student and viewing this. We have 3x minus 5 times 0 equals 30. What's x? Well, 3x minus 5 times 0 is 3x minus 0. And 3x minus 0 is 3x. And if 3x equals 30, and we get x just by dividing both sides by 3, we get x equals 10. Okay. Now, this tells us something about the graph of this function. So if we're starting to make a graph of that's terrible. I just logic. That's about right. It wasn't incorrect. That's not the way you think about it. If y equals 0, then we can do this and solve for x, and we get x equals 10. So the point 0, 10 on the graph. Down here, I'm going to draw my graph. Here's x. Here's y. We have the point 0, 10 on the graph. 0, 10. We can just pick a point on the y-axis and call it 0, 10. Rather than have a grid marked out with a scale on it, if you don't know what scale to use for the graph, you can just do this. Now that you know that this is 10, you know that this is 10 units here. And then you can divide the graph up and make a scale. We'll do that in a minute. But first, we're going to find if y equals 0, we're going to find x. So can you do that? We need to stop a minute. See, how do we find x if y equals 0? And look back to what we did. If y is 0, then we found x. If y is 0, then we just plug in y equals 0 and we have an equation that we can solve for x, right? Now, oops. Copy down what I have here. There's a rash of wrong things here. Let me see if we can set it straight. Okay. We've already done if y equals 0. Okay. But we did find x if y equals 0. If x equals 0, then what? Okay, well, we say we're going to find y if x equals 0. And again, when we assume y equals 0, we plug y in here and solve the equation for x. If we know x, if we could say if x equals 0, then what? If x equals 0, we put in 0 for x and solve for y, can't we? So see if you can do that. If x equals 0, you just plug x equals 0 into this equation and take what you get. Okay, so if x is 0, we're going to replace it by 0 up here. So if x is 0, then we get write it like this. 3x minus 5y equals 30 becomes 3 times 0 minus 5y equals 30. Okay? So if you write the equation here, and then wherever you see an x, replace it by 0, you'll have an equation you can solve for y. So we get 0 minus 5y equals 30, which means minus 5y equals 30. And I'll have to kind of finish it up over here. So we get minus 5y over minus 5 equals 30 over minus 5. So that y equals negative 6. So previously, we saw if y equals 0, x equals 10. And I must have gotten up out of the wrong side of the bed last night. So 0, 10's on the graph. It's not right. I'm going to redraw all of this. And if you're watching this video, you have my apologies. Kind of focus on some of the algebra I'm seeing here. Not paying enough attention to what I'm doing up here. Okay, so yeah, the 0.10 zeros out here, not up here. Now we put it out a little ways along the x-axis. And there we have a reasonable picture of what we call the x-intercept. The x-intercept is what occurs when y equals 0. Now, if x equals 0, then as you just saw, we can solve for y. Okay. X equals 0, y is -6, and 0.0, -6 is on the graph. Now I've got 2 points on the graph, and it turns out that this is the equation of a straight line. If you do what you did for homework and plug a bunch of x's in and find y, you're going to find that you have a bunch of points that lie along a straight line. Since the line is straight, all we need is these 2 points and we can graph it. So now we simply sketch a line. There's only one possible straight line. It's a straight line for 3x minus 5y equals 30 for this equation. And what this means is every point on this line is a solution for this equation. And this is a big deal. And if I can find my red chocolates, the other things up here. Okay. Every point, I put a point here, point here, point here. Every point on this line satisfies 3x minus 5y equals 30. In addition, any point that satisfies the equation is going to be on this line. And that's a big deal. This line completely represents this equation. And we're going to do this a little more quickly. We got 5x plus 4y equals 60. We want to find x if y equals 0. What equation do we get? Okay. If y equals 0, what is our equation going to be? Kind of like fill in the blank. I just want you to tell me what the equation is in each case. Okay, so the equation becomes what? Well, y is 0 in this case. So we're going to replace y by 0. I did recommend that we write it out the way I wrote it out before. Okay, but it comes down to this. Okay. And then find y if x equals 0. Well, here's our equation. Now, I recommend that you write the equation down as it is, and then see how y is being replaced by 0 in this case. Write the equation down like this. Write it down again here if you need to. And then replace x by 0 because it's told that x is 0. So this is 5 times 0 plus 4y equals 60. Okay. Now I'm just going to write out the solution. I'm going to move this horizontal line. We get x equals 12. Solution here, y equals 15. Okay. Now the steps of the solution are the same as steps before. You know, 4 times 0 is going to be 0. That'll leave you with just 5x equals 60. Because 5x plus 0 is just 5x. You get 5x equals 60, divide both sides by 5, you get 12. And similarly down here. Those are straightforward steps. So now, y0x is 12, so the point 12, 0 is on the graph. If x equals 0, y is 15, so the point 0, 15 is on the graph. So now we can sketch our graph. We can put the point 0, 15 on the graph. And we can put the point 12, 0 on the graph. You can draw the straight line. And there we have a graph. Okay, our camera just zoomed back to someplace in Europe where we got really tiny. Hopefully that occurred after I've written all this out. Here we have it. Okay. So those are the steps. Now, get from this point on the graph to this point on the graph, we can move over horizontally. And we can move down vertically. Okay. Now, how far do we have to move to get from here to here? And we'll discuss this. Okay, everybody's able to give me a good answer to this question. Okay, how far do we have to move this way? We got to move 12 units. Because we're going from a point where x equals 0 to a point where x equals 12. Notice that implicitly, this is horizontal and this is vertical, which means you got a right angle here, which means this makes a rectangle. So this distance has to be the same as this distance. And this distance clearly goes from x equals 0 to x equals 12. So this is 12. Okay. This here, well, the distance is 15, but we're going down. So we're going to say this is negative 15. From here to here. And if we draw an arrow mirroring this arrow over on the axis, we see that we got to go from y equals 15 to y equals 0, and that's certainly negative 15. Okay. Now we give these numbers names. Well, we call the run because negative 15 is the rise. Okay. Now at this point, stop and think, where are we seeing the words rise and run, and what do those words mean, and how do you use those ideas? Okay, so what does rise and run mean? Hopefully you've seen the words. Hopefully you remember that slope equals rise divided by run. So the slope is 12 over negative 15. And this reduces to negative 4 over 5, because you divide 12 by 3 and divide 15 by 3, you get 4 and you get 5. And you have that negative sign, so you have negative 4 over 5. Well, let's look at this line you just did. From this point to this point, what's the rise and what's the run? Okay, so I've used red for the rise, run, and the slope. I've used red for something else here. I want to know what the rise is from here to here. So, rise and run. Okay, we did well there. To get from here to here, well, getting a little clutter on this picture, but here's the rise. Okay. And the rise goes from here to here. The rise is upward. It's positive. Okay. So we're going from negative 6 and we're ending up at 0. Why do we end up at 0? Well, because that's where we've got to start if we want to move in the x direction to get to this point. There's our path from this point to this point. And we see pretty clearly that the rise is 6 and the run is 10. Okay. They're pretty small. It says rise plus 6. I put an equal sign in there, but it's a little cramped. And the run is plus 10. Okay. So the slope, what's the slope? Okay. Well, if the rise is 6 and the run is 6, the slope is always rise divided by run. And that is 6/10. Rise is 6. Right there it is, 6. You can see it. The run is 10. That equals 3/5. And it also turns out to equal 0.6. All right. So take the equation. Well, the equation 5x plus 4y equals 60 as slope -4/5. Now, solve this equation for y. Okay. Solve this equation for y. We don't have an abundance of time, but I think I can make this. See if you write this equation down, and what steps would you take to solve it for y? Okay, we have to solve this equation for y. Well, again, we start out by writing the equation. We want to solve for y, so we want to isolate y on this side. So what do we want to get rid of on this side? What we want to get rid of is the 5x. So we write out 5x plus 4y with some space equals 60. And then if we want to isolate y, we subtract 5x. 5x minus 5x is 0. This leaves us, I'm not going to write out every last detail. This leaves us 4y equals 60 minus 5x. I will emphasize the fact that we write this side down and we write this side down, and then we add or subtract something to both sides. Same thing. Okay. Now we get down to here. Well, now we solve for y. It's real easy. Oh my gosh. Okay. Got a mistake over here. Divide both sides by 4. And we get y equal, well, 60 minus 5x over 4 is 60 over 4 minus 5x over 4. This is by the distributive law. So y equals -5/4 x plus 15. There's no equation. Now look at what I did over here when I first introduced the idea of slope. I said it's rise divided by run. Then I wrote down the first number I saw, or the second number I saw. It's 12 over 15 without thinking. Somehow, the brain is not properly engaging this morning. I apologize for that. But the rise is -15, and the run is 12. This reduces to -5/4. No, I'm stealing my own thunder by making stupid little mistakes. So try not to do that yourself. Again, I apologize because that's misleading and confusing. Okay. When we solve this equation, the equation that gave us this slope, when we solve the equation for y, what do you notice? You see the slope in this equation? What's the slope? It's -5/4. See -5/4 anywhere in this? Okay. So here's the slope. And what's the significance of 15 in this equation? In this graph. Well, the graph goes through the point 0, 15. This is the y-intercept, goes through the y-axis at 15. So this is the y-intercept. We can do the same thing. This equation. Oh, let's see, I'll solve this in green. Now, I'm not going to take the time to write the steps, but everybody should be able to solve this for y. Just imitate what I did here. You're going to subtract 3x from both sides, and that'll give you negative 5y. You got 30 minus 3x. You're going to then divide both sides by negative 5, and you're going to get y equals. And let me make sure. Yeah, works out 3/5 x minus 6. Okay. Now this is what you get if you solve for y. Look at 3 dots here, which means we do some steps that we should be able to do pretty effectively at this point. So we solve for y, we get y was 3/5 x minus 6. What does 3/5 have to do with this graph? It's the slope. What does negative 6 have to do with this graph? It's y-intercept. It's where the graph goes through the y-axis. So the big deal here. Equation y equals mx plus b. Has slope m and y-intercept b. Here's m and here's b. So if you have the equation of a straight line, and I haven't really told you what characterizes an equation of a straight line, Open Math will develop that for you, okay? If we have the equation of a straight line and solve it for y, the number in front of x is the slope, and the number that doesn't have an x in front of it is the y-intercept. And that gives you enough information to sketch the graph. So we see 2 ways of sketching the graph for the straight line. We can find the intercepts, sketch the graph, okay? Or we can use the slope and the y-intercept as a means of sketching the line. We don't have time to do that today, but Open Math will run you through that very nicely.